So on this question, we're asked to take a look at redox systems 2 and 4. So I've written them out again, and I suggest you do too. I've put my thoughts on here. This one goes forward because it's most positive. This one goes in reverse. We can also see this has got 5 electrons and 2. So we're going to have to times this one by 2 and this one by 5. So if you do that, and then you combine them, with this one going forward and that one going backwards, you get to this equation here. This gives you 1 mark if you get as far as here. But what you've got to realise then is that the H pluses will cancel. And this will go to 6H plus here. And the waters, we've got 5 waters here, so they cancel down to 3 there. And you get 2 marks for that answer. Drawing the electrochemical cell then, just make sure you put solution lines in, that you haven't forgotten those. Make sure your metals definitely dip into that solution. Make sure your salt bridge dips into that solution. So on the one side we've got zinc and zinc 2 plus, the other one is platinum with Fe2, Fe3. You must label your salt bridge and you must put a voltmeter with a V in it. In terms of conditions, the only ones you actually need for this are 298 Kelvin and 1 mole per dm cubed, because there are no gases. If there was a gas involved in it, H2O2, then or chlorine, you would then need to put in that you've got 1 atmosphere or 100 kilopascals. Predicting cell voltage, it's your most positive, which is this one. Take away your least positive. So it's a takeaway. So that gives you that when you pop it in your calculator. The multi-choice then, before you look at these answers, or you can look at them, you're looking for whether things are oxidized and what the cell potential is. So collect your thoughts properly first of all, and then match your thoughts to an answer. So this one goes forward and this one goes backwards because it's the least negative. That means the tin is being reduced, it's gaining electrons, and the aluminium is being oxidized, it's losing electrons. The cell voltage is therefore this one. Take away this less positive one, and that gives you this number. So that narrows you down to having to be either that one or that one. And when we look at it, we want aluminium is oxidized. So A is the correct answer for that one. So on fuel cells then next, the difference between the two, the things that they really want you to emphasize, that it's a fuel and it's oxygen and it's giving you electrical energy from fuel and oxygen combining. Advantages of ethanol over hydrogen. They were just looking for something simple. Ethanol's a liquid, or it's easier to store, or it's easier to transport, or even hydrogen is explosive. Anything along those lines there. The equation for the overall reaction, they've told you it's the same as complete combustion. So write your combustion equation down for that one. Now deducing the other one. You've got a choice here. You can either try to work it out, because they've given you this bit, they've given you the ethanol going to CO2 at the top of the question up here. And that means you've got to do the other half, which is oxygen to water. So you can go oxygen, water, 4 hydrogens, 4 H plus, therefore 4 electrons. Your alternative is, remember that one, because oxygen half cell is always that one. And then we've got oxidation numbers to show that oxidation and reduction take place. So you're going to have to work out the oxidation number of the carbons here, and the carbons here, and the hydrogens and the oxygens all the way across. And when you do that, when you work it out, you will find that the carbon goes from -2 to +4, and the oxygen goes from 0 because it's a gas up to -2 because it's in a compound.